Well, welcome to our lesson on vectors. We need to start with an absolutely insane video. Please notice the wind. As you're watching this, think about which way is the wind blowing. Now, as you watch this guy, as we start to think about the way that he's pointing his plane, why would he be pointing his plane in that direction? So if we think about, he physically is pointing his plane this way. So the velocity of the plane is this way. The wind is blowing this way. But what direction is his plane actually going? It's actually going down the runway. And so we call this his result. The result of these multiple things happening is one motion. He's going down the runway. So let's watch him go a little bit. So here we go. If you look, the direction of the plane is straight down the runway. Look what happens when he points the plane directly down the runway. Which way does his plane go? Off to the left. So when he tries to point his plane down the runway, so the velocity of the plane is this way, the wind blows this way, which way did his plane go? His plane went that way. The result was the motion that he doesn't want. And so this is just a way to get us started thinking about vectors, is that a vector is an arrow and it represents a property of some sort. And so we're going to start playing. All right, so here we go. All right, where to look in the book for this is, if you look section 3133, another spot to look is also 3.4. Please note that there isn't a 3.2 in there. So just a thought. A vector is a fancy word for arrow. So keep that in mind. Kai-Tak Airport. Drawing vectors, how to play with vectors. So the big thing is that we add them tip to tail, and so we need to talk about what that means. And so if I move 5 meters east, and then I go 3 meters south, what is the result of those two things? And we refer to this as my resultant. So if I have 5 and 3 and I want to add them tip to tail, well, the tip of my first one needs to be added to the tail of my second. Well, what would I have to do? I would have to move my vector over. And when I add those, my result is from the beginning of the first one to the end of the second one. We refer to this as my resultant. Mathematically, if I have a right triangle, 5 squared plus 3 squared equals my resultant squared. And then the next question would be, what about my angle? I could also find my angle by doing the inverse tangent. So if I were to ask you for this angle, I would say 3 over 5 is my ratio. Do the inverse tangent. Again, if you need trig help, please come on in. I'd love to hang out with you. I won't buy you lunch, but we'll definitely help you. So let's start with some basic stuff. So balloon descends at -6. Camera is thrown down at 20. I still don't know why you would do this, so go with it. What is the initial velocity of the camera? Well, you throw it 6 downwards. You throw it additionally 20 downwards. So you're going down 6. You throw it at 20. So your initial velocity is 26. So if I were to do a kinematics equation, my acceleration is still -10, but my initial velocity is -26. And so the question would be, how long is it in the air? How fast does it hit the ground with? We have lots of different questions we could ask you. Now, we're not going to today, if that's okay with you. But the big thing is when I have two things happening, I need to take their two effects and find the result of them. What quantities in physics have both magnitude and direction? Stop right now. Write down all the ideas you have on a piece of paper. Welcome back. Here's some ideas I have. Displacement. if I go in a direction, it matters which way I'm going. The size or distance I go has an impact on how big that displacement is. So we refer to that as a vector. Velocity, also a vector. V for velocity. Acceleration is a vector. Up to this point, we've talked about it in terms of plus and minus, but we could also represent it with an arrow to say the acceleration is this way, the acceleration is down, the acceleration is up, all those different things. Force, that's a biggie. I can have a force to the left, to the right, but the fact that I need to care about the direction matters. These are known as vectors. Why? The big idea is direction and magnitude are very, very important, and that's what makes up a vector. Vectors are quantities with magnitude and direction that add and subtract like displacements. What is a quantity that does not have a direction, such as speed? What do we call those? There's some people out there who are like, yes, I know. Scalars, because it's just a scale. It's a very important word that you know that. Let's talk. What are some things that are scalars? Pause. Think about things in your life that are scalars. Welcome back. Scalars. IQ, speed, distance. Distance doesn't care about which way you go. Temperature. Who cares if it's going up or down? That's a change idea. But temperature has no direction. Time has no direction. Mass has no direction. Energy has no direction. Power has no direction. These are the two that the AP test, multiple choice, always asks about. But the big idea is these have no direction. If I have an object going this way, or if I have an object going this way, they could have the same amount of energy, but I wouldn't refer to it as a vector. But I could say its velocity is going in opposite directions. Those are vectors. All right, here we go. What does it take to be an equal vector? Nice thing about vectors is if I want to say I have a vector equal to that red one, just as long as I have the same direction and magnitude, they are equal. Doesn't matter where I'm at. Nice thing is, I'm going to click backwards. Nice thing is what that means is I can move them. I don't have to keep them in one location. I'm free to move vectors. Now, if they're not parallel and they're at right triangles, I think it's okay to say we can do a squared plus b squared equals c squared. We're going to help you figure out what to do when that's not the case. You walk 3 kilometers east and then 4 kilometers north. What is the resultant displacement? Write this down in your comp book and actually do it. All right. If you haven't noticed yet, you need to pause when I say do it. And so when I think about what its displacement is, a squared plus b squared equals c squared, so I'm going to get 5. What if they were to ask you for this angle? What would I do? Well, this is my opposite side, this is my adjacent side, and so I could say the tangent of my angle is opposite over adjacent. Theta equals the inverse tangent of 4/3. Those of you that are still new to trig, on your calculator you just hit second tangent and then put 4/3 inside, and it's going to give you your angle. Trig 101, if you don't know it, right triangle relationships. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So ka toa is the way that we remember all this stuff. Please fast forward through this if you're good. When we say opposite, if this is my angle, this side is opposite the angle, this side is next to. Fancy word for next to is adjacent. Hypotenuse is always the big one, and it's across from my 90-degree angle. Now, here's what's important. We did this with velocity. So I had a velocity here of 100, and this was 30 degrees. I broke that into pieces. And so when I broke it into pieces, I knew the x and the y value. Well, now the review to say it is the x direction is always the overall times cosine. The y direction is the overall times sine. Angles, again, we talked about that. So car travels 20 kilometers in direction 30 degrees north of west. So this is west. North of west means north of west. So 30 degrees is going to be here. Find the x and y components of the displacement. So I need to find my x and I need to find my y. So if this is 20 kilometers overall, this would be 20 cosine 30, and this side would be 20 sine of 30. Now, here's where it gets interesting. What if they're not at beautiful, nice, right triangles? Well, here's a nice thing we can do. I could take vector A here, and I could find its components. Then I could take vector B here and find its components. Well, the result of these two is this big guy. But if you look at this big guy, how do I find it? I've got how far this one is in the x. I have how far this one is in the x. I have how far this one is in the y. And I have how far this one is in the y. And if I add those together, now all of a sudden I have a big triangle. I've got a number here. I've got a number here. And so I can find this, the total, which we call the result right here. Now, we have a couple web assigns off those old ones, but at this time I'm going to bring up a special problem. I'm going to take a boat, I'm going to point it directly across the river. What path does the boat actually take? That's the question of the day. So I've got my river, I have my boat, and I point it straight across, and it has a velocity. Well, if the river has a speed to it, velocity of the river, what's going to happen to my boat? Which way is it going to go? I pause for dramatic effect and also give you a chance to guess. Is it okay to say the boat's going to go that way? Oops. The result is going to be this motion. So we're going to take this step by step here. Step 1, how wide my river is. Step 2, velocity of my water. Step 3, my velocity of my boat. Is it okay to say that this is the path I'm going to take here? And D is going to be how far down river. Thus the word D for down. It's a joke, or the bad one. If I draw my vectors, and I have to always do this, tip to tail. I take the tip of my boat and I attach it to the tail of my river, water. My result is this. This is the actual speed of my boat. Well, how do I find it? I could do a squared, b squared, c squared, but wouldn't it be nice if we had some information? So number 1 is how fast you're actually going. So what I would like you to do right now is write this down. Actually do this in your comp book. And this is called boat crossing a river. Let's assume the river is 100 meters across. Boat can power itself at 12. The river is running at 3. How fast are you actually going? That's step 1. Do it. So if I'm moving at 12 and the water is moving at 3, I can say the velocity that I'm actually going is 12 squared plus 3 squared, but the square root business of all that. What angle are you going at? Well, could I say the tangent of my angle right here is 3 over 12. So theta equals inverse tangent of 3/12. And you get a number. Very important that you write this number down. We're going to use that in a second. Next question is, how far downstream do you hit? Many ways to do this. I want to encourage you to stop, try to think of a way to do it. one of the ways to do it is to say my boat's going at 12 and it's moving at 3 and my result is this value. So this is a picture of my velocities. But I could also draw a picture of my river. This is 100 meters across. That's where I actually go, and this is far how downstream I'm going. This is what I want to solve for. Well, if I know my angle here, I know my angle here. These are equal. So you could do trig. Okay? If you're not a trig person, another way you could do it is you could say, well, I go 3 meters per second down the stream, I go 12 meters per second across, so I could say my ratio of 3 meters per second over 12 meters per second equals d over 100, because I have similar triangles. And so I could say these sides over each other are in ratio to solve for the distance downstream. You could also do it a trig way. You're going to get the same solution. Next one. How do you get your boat to go straight across the river? What do you need to do? Well, think. Predict. Here's my boat. I want this. I want to do this. Which in the river is still going downstream. How do I need to point my boat? Hopefully you said upstream. So my velocity of my boat upstream is going to be 12, but how much is the water pointing downstream? 3. Well, knowing that, the question is, what angle do I need? So option A, same as last problem. Option B, different. I want you to pick A or B. I want you to commit to one of these. Do you think it's going to be the same angle, or do you think it's going to be different? And if it's different, guess. Is it going to be less? Is it going to be more? Same's already taken. But if you think it's going to be different, predict. All right, here we go. Time required to go directly across. That is the question we're going to answer. I know how far across it is. It's 100 meters. Well, if I know how far across it is it okay to say the velocity is displacement over time? And so if I know I want to go 100 meters, I'm solving for time. What do I need to solve this problem? I need to find my velocity across the river. So that's where we start. I have a velocity of 12 this way. Water is going this way at 3. How would I solve for my velocity across? Hopefully you're saying a squared plus b squared equals c squared. This is where it gets tricky. 3 squared plus v squared equals 12 squared. Notice that this is now the hypotenuse, because my 90 degrees is right here. So I get 9 plus v squared equals 144. So I get a velocity of the square root of 135, which is a number. This is the velocity going across the river. So could I use that velocity, plug it in here, solve for time? That's it. Very important though is that this is the hypotenuse now. And if I look on the previous part, this 12 was not the hypotenuse. So am I going to get different numbers? Yes. For fun, we're going to leave you with this. Solve for the angle. If you don't know how to solve for the angle, come on in, hang out, we'll walk through it. But solve for this angle, and I want you to do is compare it to the previous problem.